Hello and welcome to the GCSE exam questions on energy changes. So this is energy change in chemistry. Okay, so these are real exam questions. They've been taken from real papers. So sometimes the numbers seem a bit strange because they're taken from different papers. Okay, so they can be obviously in real paper mixed in with the questions, but I've just taken some of the energy bits out for this video. So let's read the first question. Many transition metals are used to make the reactants in chemical cells. Figure 8 shows a graph of the voltage produced by a chemical cell as it is used in a torch for many hours. So some people say this looks like it's from a physics exam, but it's not, it's from a chemistry exam. Okay, so voltage, so it's fluid energy. Suggest an explanation for the shape of this graph. So let's look back and read that again. So it's a graph of the voltage produced by a chemical cell is used in a torch for many hours. Okay, so it's a chemical cell, so it's a chemical reaction. So the voltage, oh, let me turn my pen on here. So the voltage is produced by a chemical reaction in the battery. By a chemical reaction in the cell. Well, if it's more than one, so it's a battery. I'm going to say cell because I use the word cell. Okay. The voltage, so because it's in the chemistry exam, so you've got to think of it in terms of chemistry. So that's why it's put in there. The voltage decreases over time as the reactants are used up. Okay, so yeah, so it's actually it's a chemical reaction creating an electrical current. So it's actually the reactants that are being used up. It's a chemical cell. Okay. In another experiment, a student investigated the temperature decrease. So in this time we're looking at energy in terms of temperature. So there's lots of ways that energy can be asked about. So thermal energy this time. So we had electrical energy in the last one, we've got thermal energy. Okay, so in another experiment, a student investigated the temperature decrease when different amounts of ammonium nitrate crystals were dissolved in 100 centimeters cubed of water. So ammonium crystal dissolved in water. The apparatus is shown in figure 5. We have a beaker, a polystyrene cup, like one that you might get from like an event with tea or coffee in it, and a thermometer. The student used the following method. Step 1, pour 100 centimeters cubed of water into the polystyrene cup. Add 1 spatula of ammonium nitrate crystals to the water. Step 3, stir the mixture. Step 4, use the thermometer to record the lowest temperature reached by the mixture. Okay, this is a clue, isn't it? It's an endothermic reaction. Repeat steps 1 to 4 using different amounts of ammonium nitrate. Okay, so the variable there is they're going to use different amounts. So let's name a piece of apparatus that could be used to measure the 100 centimeter cubed of water in step 1. So an easy one would be a measuring cylinder, wouldn't it? You could have said a syringe, a pipette. Probably the easiest would be a measuring cylinder, wouldn't it? So it's a funny word, is it cylinder? I looked at that. The student cannot work out the temperature to decrease using the method described. State what the student must do before step 2 to be able to work out the temperature decrease. Okay, so what they've missed out there is actually they haven't recorded the starting temperature. That's an easy mistake to make. So the main must do, so they have to record, so write down the starting temperature. Okay. State why a polystyrene cup is used in this experiment. So it's the same reason why you put hot drinks in it. Is that polystyrene is a good insulator. Styrene is a good thermal insulator. Thermal insulator. So less heat would be lost to or transferred from the surroundings. Okay, so we're talking measuring temperature. So you don't want to transfer it to surroundings, it will affect the experiment. Figure 6 shows a reaction profile for this reaction. Use the words from the box to complete the labels on figure 6. Okay, so got heat energy and progress of reaction. So we started here, so we've got reactants. So that's the things that go in. Okay, this is the energy needed for the reaction. So it needs to take energy from the surroundings. So it's endothermic, which you talked about. So that is activation energy. Okay, we've only got one more. So this is the products. Okay. So you've got a different question now. Tests are carried out to identify the ions in two solids, P and Q. So they're not the names of the substances. They're just sort of like you say, X and Y, so unknowns. A flame test is used to identify the metal ions in each of these solids. Describe how to do a flame test. So you probably have done this in class. So use a metal loop or a wet splint. This would be a wet splint, like when you put in water, it will catch fire, to take a small sample of the solid, place in Bunsen flame and observe the color. So the color indicates what metal ion is present. Okay. Different metal ions produce different colored flames. Draw one line from each metal to its flame color. Just one line per one. Don't have more than one. They're all done marking answer wrong. Okay, calcium. Okay, so that one's not quite as obvious. You might have done that one, but calcium is actually orange red. That's quite distinctively see it. Potassium, we know that from putting potassium in water, lilac, so a light purple. Green would be copper. Yellow would be sodium. Oh, actually, copper is more likely to be a blue-green, I would say. Mostly green, but copper. Yellow, definitely sodium. Green, it could be barium. The other one's not quite as common, okay? Figure 8 shows apparatus used to find out if a solution conducts electricity. So you've got electrical energy again. Well, inert electron. Inert means it doesn't react with the solution. So glucose solution, so sugar, glucose solution and sodium chloride solution are tested. Glucose is a typical simple molecular covalent compound. So we're told what it is. So remember, it's C6H12O6. Sodium chloride is an ionic compound. State what would happen to the lamp when the glucose solution is tested. So glucose solution does not conduct electricity. So the bulb would not, or lamp would not light. It would not light. State what would happen to the lamp when sodium chloride solution is tested. So it's ionic, so it's dissolved in water. It conducts electricity, so the lamp would light. Sure, they would give you marks for saying turn on, light would turn on. Okay, so we've got a graph, so increasing conductivity and concentration of solutions is the sodium chloride in grams per dm cubed. Describe how the conductivity of this solution changes as its concentration increases from 0 to 500. So it's 2 marks there because it's in 2 parts, isn't it? So the conductivity peaks about here. So it peaks at 150. So the conductivity of the solution, this is only 2 marks, so you have to write 2 statements really here. The conductivity of the solution increases with increasing concentration until 150 grams per dm cubed. After this, conductivity decreases. Until 500 grams per dm cubed. Okay, it looks like it will level out, but we don't know if it will keep decreasing. We don't know from this diagram. Okay. Zinc metal reacts with dilute hydrochloric acid to produce hydrogen gas. That's about zinc does react with things. So zinc plus hydrochloric acid goes to zinc chloride plus hydrogen. A student investigated the effect of doubling the concentration of the hydrochloric acid on this reaction. So the concentration is being doubled, not the volume or anything else, the concentration. The student made the following prediction. When the concentration of the hydrochloric acid is doubled, the rate of reaction will double and the reaction will be more exothermic. Devise a plan, including apparatus you would use to test the student's prediction. You're provided a piece of zinc and 2 bottles of dilute hydrochloric acid. 1 bottle of dilute hydrochloric acid is double the concentration of the other. Okay, so let's think about what we're going to say. Zinc, so you've got zinc. So let's think about equipment list. So I'm going to write over here. So equipment. You can draw things as well. Okay, so we want exothermic. So there's quite a few things here to note, isn't there? So it's temperature change. So we could take a bit of inspiration from the other experiment with the temperature change. So we could have the beaker with the polystyrene cup in it. Okay, so always take inspiration from the paper because they usually put it in there for a reason. Beaker, polystyrene cup. Okay, so we need a thermometer. It's got gradations on it. Okay. Okay, so that's so equipment, paper, polystyrene. So also we need a balance to measure the mass. The mass of zinc. We need a measuring cylinder to measure the volume to measure the volume of hydrochloric acid. We need a stopwatch for a time, don't we? There's a lot more to this little first thing, isn't there? Quite a 6-mark question. Okay, so now we can start writing a method. So number 1. So we can have two sets of this, couldn't we? So 2 polystyrene cups, so identical ones, same packet, in 2 beakers, so they're both identical. Okay, 2 polystyrene cups with identical thermometers, so same type of thermometer as well. So 2, measure 20 grams, so it could be any sort of sensible measurement will be fine, of zinc on the balance for each cup and place in cup. So and then measure, so a lot of things have got to be the same, haven't they? Measure 100 centimeters cubed of dilute HCl with hydrochloric acid and 100 centimeters cubed of the double concentration. Okay. So, okay, so place, so do you should do it at the same time. So pour both into the cups. So the hydrochloric acid. So measure starting temperature. So 5. So leave for 10 minutes. Take readings every minute. Look at 6. Called final results. And then 7, repeat experiment twice more to verify results. It was good to repeat it. Okay. So yeah, an exam, don't worry about room. You have quite a lot of room in the exam to write this. Okay, my writing's quite big on here. And you can also ask for extra paper. But thank you for listening. Yeah, the 6-mark questions, they require a bit of planning like that to write. Okay, so good luck in your exams and hope to see you in another video. Thank you and goodbye.